Hello everyone, this is Ravteja. Welcome to my channel. In this video, I'm gonna discuss about the project named called Temporal Information Retrieval. Let us discuss what is temporal information retrieval. Uh, we know the traditional information retrieval systems focuses only on how closely the text in the document matches the query. However, in many real-world scenarios, time plays a crucial role in the relevance. Information becomes outdated, new findings will emerge, and user expectations will evolve. Therefore, simply matching the keywords is not enough. This is where the temporal information retrieval system will come into the picture, which is enhances such systems by incorporating the recency of information, ranking the documents not only on what they are saying, but also when they are created. Let's discuss the one of the real world scenario like COVID-19 travel guidelines. If search engine returns article from 2020, they may be irrelevant today, even if the text matches perfectly to the COVID-19. But the article from the last week about the COVID-19, even if it is slightly less textually similar, it is more useful. The difference is exactly what temporal information retrieval system solves. The temporal information retrieval consists of some of the important steps involves um, text pre-processing and calculation of term frequency, which is also known as TF, and document frequency, that is inverse document frequency IDF, and TF-IDF calculation, which is done by multiplying the values calculated from TF into values calculated from IDF, and query vectorization by doing the same process to the required or provided query. We will be getting the query vector, and next we will be calculating similarity, that is cosine similarity, by using the formula cos theta, and finally we will be calculating the recency score by using the formula 1 by 1 plus today minus document created day in number of days. And finally, we will be ranking the documents based on the values generated with the formula alpha into text similarity plus 1 minus alpha into recency score. We will be discussing more about the steps and the example. Let me share my screen. This is the worked example for temporal information retrieval system. Here we have the document collection with document IDs D1, D2, and D3 with the text provided here and the date in which the text is generated. We will be calculating by step by step. These are the all the important steps which are mainly used in the TIR, that is temporal information retrieval. Step 0 consists of tokenization. We will be removing the special characters, and we will be converting the upper cases to lower cases. Here by tokenizing, the document 1 will consist of 5 words, that is government, announces, new, electric, rebate. Likewise, the D2 and D3 are tokenized like that. And on moving on to the next step, we will be calculating the term of frequency with the formula, the count of terms in the document by document length. Here the document length will be calculated here above. Like the length of the document here is 5. For document 2 it is 5, document 3 it is 6. The number of terms here, document length will be provided. By using the formula, the TF will be calculated for the word electric. The TF is 1 by 5. Here you can see electric in D1. Here the term electric is one time is repeated, and the document size is 5, that is 1 by 5. Likewise, the TF for electric subsidy and rebate will be calculated. Moving on to the next step, and the IDF values will be calculated by using the formula IDF equal to log of capital N by DF of T, where the capital N represents the number of documents, that is D1, D2, and D3. DF of T represent the number of times the document will be there. The word electric appears in every document, so it contributes nothing to the discrimination, that is IDF equal to 0. Here you can see for the word electric, the IDF value will be log of 3 by 3, that is log 1, that is 0. Here you can see the electric will be repeated in document 1, document 2, and document 3. That is why the IDF value for the electric is 3 by 3, that is 0. For subsidy, the subsidy is only repeated once in the document 2, that is how the values will be calculated for the IDF. Moving on to the next step, TF-IDF values. TF-IDF values will be calculated by simply multiplying the values generated in the TF into values generated in the IDF. Here the calculation will be done likewise. The final outputs will be here. By doing the similar steps for the given query, the provided query is electric subsidy. We will be tokenizing, and we will be calculating TF, and we will be also calculating the IDF for the query tokens like electric and subsidy. And finally, we will be vectorizing it. For the electric, it will be 0, and for subsidy, it is 0.54. Moving on to the next step, we will be calculating percent similarity between the document versus the query. For the document, the provided or generated values will be here for the document 1. These are the values. For cosine similarity formula, we will be having cos theta equal to a dot by mod a into mod b. Here, how it is calculated is, this is for the query, this one, and this is for the D1. Let's revise how it is getting calculated. Here 0 into 0 plus 0.54 into 0 divided by mod of 0 square plus 0.5 square into mod of 0 square plus 0 square. The final value will be 0. That is how here the values will be calculated. No overlap. For the document D2, let's see what will be happening. 0 into 0 plus 0.54 into 0.2 divided by 0 square root of 0 square plus 0.54 etc. square into 0 square plus 0.21 etc. whole square. This is how we will be calculating. The final value will be, which is relevantly equal to 1. For the D3, it will be likewise 0, like the document D1. The test relevance score will be summarized here for D1, D2, and D3. Now we will be calculating recency score, which is a freshness, that is how the data is near to the today's date. The recency score will be calculating by using the formula 1 by 1 plus today minus document created day in number of days. By using this formula, we will be getting the values like this: 0.5, 0.03, 0.002, like that. Moving on to the next step, final step, we will be combining the final score and the rank. Here we will be using test relevance and the recency score. The alpha value will be 0.7 here. The final score formula is alpha into test relevance plus 1 minus alpha into recency score. By substituting the relevant terms, that is D1, for D1, the values of test relevance and recency here, the final value will be calculated by substituting the relevant terms, and the final value will be generated here. Likewise, for the D2 and D3, the values will be substituted and calculated the final values here. The final scores will be summarized here for D1. By observing this, we will be come to know that the value will be higher for the document D2, and next one will be D1, and the third ranked one will be D3. Here you will be thinking why that D2 will be ranked first. That is, D2 wins because it contains the unique discriminative term subsidy. D1 benefits from recently but lacks the key term, so it comes second. D3 is old but not query relevant, it ranks last. Let's see here. We will understand by looking into the picture. Here you can see our query is electric subsidy. Here you can see that the subsidy term is only present in the document D2. That is why the document D2 ranks first. And coming to the next one, why D1 is ranked second is the today's date is 31st November, which is near to 29th October 2025. That is why by the help of relevance score, it will be ranked second, and the remaining one will be ranked third. This is how the temporal information retrieval system works and calculated. Let's move on to how the code works. These are the libraries. This is how we will be loading the data set from the CSV file for test pre-processing and calculating TF. Like this, and this code is for calculating IDF values, and this is for TF-IDF vectors, that is multiplying TF and IDF. Here calculating recency score with the formula 1 by 1 plus today minus document created day in number of days. Here the recency score we can see here. TF-IDF strengths will be provided here. Final rankings. This is how the final output will be generated here. You can see that is the document 8, which is research so battery recycling can reduce. That will be ranked first. This one will be shown in the graph like this. The document which is ranked 8 will be higher than the any other bar graph here. For the query processing, the another one will be generated here. For government electric subsidy query, the graph will be generated like this, the third one. This is how the temporal information retrieval system works. To conclude, temporal information retrieval system is becoming increasingly essential in today's fast-moving digital world. Traditional search engines rank documents only by textual similarity, assuming that the relevance is timeless. But in many real scenarios, news, research, traditional time changes meaning. What was once relevant may no longer hold the same value today. That's it for the presentation. If you like this video, please share and subscribe. Thank you.